Hi, my name is Scott Flansburg, and I'm known as the human calculator. I can do things in my mind faster than a calculator. I can add, subtract, multiply, divide, and do all kinds of different mathematical equations in my head. And it's all because when I was very young, I tried to make numbers fun. I learned the way they taught me in class, and then I always tried to figure out a little bit different way to do it or an easier way to do it. When I was in 4th grade, my teacher had a column of numbers on the board to add up, and I didn't hear her say to start on the right, and I actually did it backwards, and it made much more sense to my mind. And from that point forward, I've always tried to figure out secrets and tricks to numbers and how they work. So today, a lot of you listening are probably very afraid of numbers or even hate numbers. And the only thing I want to get across to you is that numbers are a language just like English and the alphabet. English is spoken with the letters A through Z. Numbers use the digits 0 through 9. And so before we get into any math, I want to make sure you understand the alphabet of numbers and math. So let's start at the beginning. These digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are the 10 digits that are used to make up all numbers in the universe. So there is something fascinating about these numbers. If you notice, they're all a single digit. We usually think 1 through 10, but look at 10. 10 is a number made up of 2 digits, the digits 1 and 0. Watch what happens with all numbers higher than 9. Let's add up the digits inside of 10. What's 1 plus 0? You get 1 and just put it underneath. And if you subtract it from the original number, what's 10 minus 1? You'll get 9. Let's try 11. 1 plus 1 is 2. So put a little 2 and subtract it. What's 11 minus 2? 9. Let's try 12. 1 plus 2 gives us 3. So if you subtract 12 minus 3, you'll get 9. You'll see that it works for all numbers in the whole universe higher than 9. What if we picked 37? Add them up. What's 3 plus 7? That gives you 10. So put it underneath and subtract it. What's 37 minus 10? The answer is 27. And 2 plus 7 equals 9. If you have any trouble with your addition tables from 0 plus 0 up to 9 plus 9, just use this simple technique and you'll never get another problem wrong. What if I asked you 5 plus 5? Just use the number 55 to check 5 plus 5. What do you think 5 plus 5 is? Obviously, we think it's 10, so we do this little subtraction. What's 55 minus 10? You'll get 45. Now, what's 4 plus 5? That's 9. That means that 5 and 5 is indeed 10. If you thought it was 11 and you put 11 here, you'd get 44, and that doesn't add up to 9. So if you understand this basic principle that all numbers higher than 9 actually add down to 9, I promise you will never get another addition problem wrong. Now we're going to try addition. You know that the digits are 0 through 9. Anything over 9 plus 9, like 10 plus 10 or anything higher, we usually shut off our brain and use a calculator. What I'd like to do is show you that any one of you watching today can add up columns of numbers in your head very simply. So give me just a chance, and I'd like to show you the very simplest way to add up numbers. What if we started with 12 plus 13? Something very simple, more than 10 plus 10. You usually start over here and do 2 plus 3 is 5, and then 1 plus 1 is 2, and there's your answer. But just for fun, try it backwards. It's like reading left to right. This number here is in the tens column, so that 1 just means 10, and that means 10. So what's 10 plus 10? 20. And then we just go up here and add the next one. So what's 20 plus 2 is 22, and 3 more is 25. Let's try another example. What about 14 and 15? Just try it left to right. What's 10 and 10? Is 20, plus 4 more is 24, and 5 more is 29. Now, what happens if we have to carry? 14 plus 16. Instead of starting over here, remember we're starting over here on the left, so what is 10 plus 10? Still 20. Let's go up here. What's 20 plus 4? Gives us 24, and we add 6 more, and what do you get? You should get 30. Do you see how it automatically carried? You don't have to carry using this technique of left to right addition because you just keep a running total down the columns and it will always add up. Let's try 17 and 18. 17 plus 18, we start at the 10. 10 and 10 is 20, plus 7 is 27, and 8 more gives you 35. Do you see how it totally eliminates carrying? And it makes all addition problems very simple because once you do that number, you never have to think about it again or remember it because it's in your total as you're going down the columns. So just for fun, I want to show you how amazing this works with larger numbers. What if we did 24 and 15 and 11 and 12? Most of you wouldn't even try to do 24 plus 15 plus 11 plus 12 in your head. Only way you could do it is add them up and carry and such. But watch how easy this is for your mind. This 2 is in the tens column again. 2 tens is 20. Down here is 10 more. So what I'd like you to do is keep a running total, and we're going to go down the columns backwards. So what's 20 plus 10? That gives you 30. If you add 10 more, that's 40, and 10 more gives you 50. Then we go up here to the next column. 50 plus 4 gives us 54. We add 5 more, and you get 59. 1 more is 60, and 2 more is 62. Let's try one and see how you do. Let's do 24, 25, 21, and 15. What's the first step? Remember, left to right, just like you read. We start with the 2 tens here, which means 20. So what's 20 plus 20? 40. 20 more gives you 60. 10 more is 70. And we go to the next column. So what's 70 plus 4? 74. 5 more is 79. 1 more is 80. And 5 more gives us 85. No more carrying. And what this allows you to do is not only just look at a column of numbers and get the answer and just write the answer down without doing all the carrying and stuff, but it also helps you with your estimation skills. When you did 20, 40, 60, 70, you know right away the answer is over 70 or even 80. But when you start the other way, you just go, okay, well that's 4 and 5 is 9, 10, 15, right down to 5, carry a 1. You have no idea what the answer is going to be, and all you've done is figured out the least important number in this answer. If you're at a grocery store and you only have $1, you want to make sure that 85 cents is under it. So this is going to help you with your estimation skills. What happens if we do this? 27, 32, 11, and 4, let's do 15. All right, what's the first step? Right here, 20. That's a 2 in the tens column, which is 20, and 30 more is 50, 10 more is 60, 10 more is 70, plus 7 is 77, 2 more is 79, 1 more is 80, and 5 more gives you 85. Before you go any further in the program, I'd like you to take the time to practice with just a couple of simple 2-digit numbers added together first. And when you've got that down, move up to multiples of 2-digit numbers, maybe even a column of 3 or 4 at a time, and really get this down before you go any farther, because next comes 3-digit addition. I'm sure that all of you totally understand how to add up a column of 2-digit numbers now, and it makes perfect sense to you every time. So just for fun, let's try some 3-digit numbers because I just want to show you that it works for all numbers of all sizes. Let's try 123 plus 214. The same concept works left to right. So these are your ones column here, these are your tens column here, and this is the hundreds column. So this 1 right here just stands for 100. This 2 means 200. We're still going to go left to right, and I just want you to keep a running total. So what's 100 plus 200? That's 300. And now this 2 means 20. So what's 300 plus 20? 320. We add 10 more, 330, and then we go up here. What's 330 plus 3? 333. And 4 more gives us 337. It really works for all numbers. Let's try a little bit bigger. Let's do 245, 114, and 212. Three-digit numbers. When you're going to add them up, and you're actually doing these in your head now and just writing down the answer instead of all that other carrying stuff. Let's see how it works. What's 200 plus 100? 300. 200 more is 500. Up here is a 4, which means 40. So what's 500 plus 40? 540. 10 more is 550. And 10 more is 560. And we go to the next column. What's 560 plus 5? 565. 4 more is 569. And 2 more is 571. Do you see how keeping that one number in your head, that running total all the time, takes all the stress off of trying to remember all the previous numbers and what to carry? It just allows you the opportunity to go right down the column and come up with the right answer. Let's try one more, and this time let's do 4 three-digit numbers. Now, most of you never would have tried this in your life, and you're sitting here doing it now. So we start on the left. We have 1, which stands for 100, and 2 is 200. 100 and 200 is 300. Another 100 is 400, and 200 more is 600. And we go to the next column. 600 plus 20 is 620. 10 more is 630. 20 more is 650, and 10 more is 660. And then we just go up here again. 660 plus 3 is 663. 6 more is 669. 1 more is 670, and 4 more gives us 674. I promise you that all numbers work this way. You can do 4-digit numbers, 5-digit numbers. It doesn't stop. Just start on the left. It's going to help your estimation skills and build your confidence. Now we're going to try subtraction. Subtraction is really just reverse addition. If I ask you 10 minus 5, the easiest way to get that answer is to reverse it and just say 5 plus what equals 10. So remember, whenever you're doing subtraction, it's really reverse addition. Let me give you a couple of examples. Let's start with 24 minus 12. The way that we teach kids in schools how to do it is we go 4 minus 2 is 2, and 2 minus 1 is 1, and there's your answer. But just for fun, I want to show you that it also works left to right, and it actually is easier to do in your head. This 2 here stands for 20, and this 1 stands for 10. So what's 20 minus 10? You have 10 more, and then we go over here and just do 4 minus 2, and we get 2, and your answer is still 12. The way to check your subtraction problem to make sure you're right is to go backwards. Just add it up backwards. What's 12 plus 12? And you better come up with 24. So let's try another problem and do 36 minus 25. All right, starting over here, this 3 stands for 3 tens or 30, and this is 2 tens or 20. So what's 30 minus 20? You'll get 10, and then we go over here and do 6 minus 5. 6 minus 5 is 1, so 36 minus 25 is indeed 11. To check and make sure that's right, we just add backwards. We do 11 plus 25 equals 36. So do you see how it's really reverse addition, not subtraction? Now, what if we have to carry? Let's do 42 minus 28. You can see right away we have a problem here because this number is bigger than this one. So usually you have to borrow. But watch what happens when you subtract left to right. Let's start over here again. This 4 means 4 tens, and that's 2 tens. So what's 40 minus 20? We'll get 20. So remember that. And now, to figure out what to do here, the trick is just drop this number down to right here and subtract this number right here. So what's 22 minus 8? It's 14. And if you check this, 14 plus 28 does in fact equal 42. The only difference by subtracting left to right like this is that you can, once again, do it in your head, and it helps you with your place value as well. Let me give you one more example. What about 53 minus 36? What do you think it's going to be? If you go to the left side, you know right away it's around 20, because 50 minus 30 is 20. And then once again, just sneak that number down here and subtract that 6, and 23 minus 6 gives you 17. So now I'd like you to go and try some subtraction problems, and remember, reverse it and make it an addition problem. Just for fun, let's try some 3-digit subtraction. It still works just like it does for 2-digit numbers, 4-digit numbers, or any number larger than that. Let's try 246 minus 123. Same thing, we go left to right, and all you do is keep that running total. So what's 200 minus 100? You're going to get 100. And then 40, because that's in the tens, so 40 minus 20 is 20. And then 6 minus 3 is 3. And if you do it backwards, you'll see that 123 plus 123 equals 246. So let's try another one. What if we had 357 minus 225? Go ahead and give that a try. Starting over here, 300 minus 200 will give you 100. 50 minus 20 is 30. And then 7 minus 5 is 2. So it still works. And if you do it backwards, you'll see that 132 plus 225 does indeed equal 357. What happens if you have to borrow like you did with the old way? Let's do 324 minus 125. Now there's a lot of work here if you had to do it the other way because you got to borrow. But let's do it left to right and see how it works out differently. Just go here, 300 minus 100 gives you 200. Now, 20 minus 20 is a 0. So right now, there's a 200 here, but this number is smaller than this number, so we have to do that little trick where we bring this number down, 204, and then just subtract that number, which is 5. 204 minus 5 will give you 199. 3-digit subtraction is a lot easier to do left to right, not only because you get the estimated answer quicker, but it helps you understand those place values of hundreds, tens, and ones. Multiplication, my favorite. There are so many ways to multiply two numbers together, and yet we usually only teach one way to most people and hope they memorize that simple technique to get the answer. Today, I'd like to show you just a few more options that you have to get the same answer with multiplication. We're going to start out with a basic problem like 12 times 14. Now, the way we teach this in schools all around the world is there's a few steps involved. You have to do 2 times 4 is 8, 1 times 4 is 4, don't forget your 0, and then 2 times 1 is 2, and 1 times 1 is 1, and then you have to add these all up. 8 and 0 is 8, 4 and 2 is 6, and 1 is 1. So surely 12 times 14 equals 168. My hesitation here is that it takes a lot of steps and there's a lot of room for confusion. It takes you 1, 2, 3, 4, 5, 6, 7, 8 steps to get the answer of 12 times 14. Plus, a lot of times people get these confused and add up wrong columns if they aren't neat with their writing. So I want to show you a simple technique that gets you the same answer, except it only takes 3 steps. It's called right to left cross multiplication. It's very simple. 3 steps. The first step is the right side. Just multiply 2 times 4. And what do you get? 8. Now the next step is the cross, multiply, and add. You multiply across, and then add those two together. So what's 4 times 1? 4. 1 times 2 is 2, and you just add those two numbers together. So what's 4 plus 2? 6. There's your second digit in the answer. To get the third digit in the answer, just multiply the two numbers on the left. What's 1 times 1? 1. And you'll see that we have the same answer, 168, except look how much neater this is, and it's a lot simpler to get to the answer this way. Let me show you that it works for all numbers. How about 24 times 15? First step is what? The right side. So 4 times 5 will give you 20. All you do is put down the 0, and you carry that 2 to the next step. The next step is the cross multiply. So what's 5 times 2? And what's 4 times 1? You should have got 10 and 4, and if you add them together, you get 14, and add that 2 we carried, gives you 16. So you write down the 6, and now we carry that 1 to the next step. The next step is the left side. So what's 2 times 1? That gives us 2. Don't forget about the 1 we carried. That gives us 3, and there's your answer, 360. Let's try one more. How about 42 times 21? First step is the right side. 2 times 1 is 2. And now we cross. 4 times 1 and 2 times 2 is both 4. So what's 4 plus 4? 8. And to get this left digit, multiply the numbers on the left. 4 times 2 is 8. Two-digit multiplication has many different ways to get the answer. This way, I think, is the simplest because it organizes the numbers for you and allows you to just write down the answer. So go back and practice this a little bit and make sure you're really good at 2 times two-digit numbers. With multiplication, we tend to put limits on ourselves and think we can only do up to 9 times 9 or 10 times 10. And what I'd like to show you is that there are all kinds of magical numbers out there, and my favorite is 11, because 11 is actually the easiest number to multiply by. Let me give you an example. Let's do 13 times 11. The trick to the number 11 is that any number times 11, there's 3 steps to getting the answer, and they're very simple. The first step is to just drop the numbers down here like this. The 1 goes here, the 3 goes here. And now to get the middle digit in the answer, all you have to do, because you're multiplying it times 11, is add those two numbers together. What's 1 plus 3? 1 and 3 is 4. And you just put it right in the middle. So 13 times 11 is 143. You can still see the 13 there from the top, and then it's just added together in the middle, and that'll work for all numbers. Let's try this. What's 24 times 11? The first step is to just bring the numbers down. 2 here and 4 here. And then what do? Just add those numbers together. What's 2 and 4? I'll put a little plus here. You should get 6, and that means 24 times 11 is 264. Let's try 35 times 11. We know that it's going to be a 3 here and a 5 here. And what's 3 plus 5? 8. So it's 385. You should be able to do this in your head rather quickly. If I gave you 44 times 11, you know that both ends are a 4. What goes in the middle? 4 here, 4 here, 4 and 4, 8. 484. Works for all numbers, but let me show you what happens if the number happens to carry or add over 10. Let's do, let's make it easy. Let's do 55 times 11. Normally, a 5 would go here and a 5 would go here. But since these add to 10, there's going to be a carry. So let's bring the 5 down here and the 5 down here. So what's 5 and 5? 10. You put the 0 in the middle and you add 1 to the 5 to make it a 6. Do you see how I did that? 5 here, and then 5 and 5 is 10. So I just added that 1 here and put the 0 in the middle. Let me give you another one. How about 66 times 11? You have a 6 here, a 6 here. And now, what's 6 plus 6? 12. Put the 2 in the middle and add 1 to the 6 and make it a 7. It works for all numbers like that, even a big one like 89 times 11. We put an 8 out here, a 9 out here. What's 8 plus 9? It should be 17. That means you put a 7 here and you add 1 to the front and that gives you 979. And sure enough, 89 times 11 is 979. So when you get a chance, anytime somebody has to multiply a number times 11, remember this little trick to just drop them down and add them together, and you'll have the answer every time. In my travels around the world to visit schools and help parents and teachers and students overcome their fear of numbers, a lot of times I run into people that just can't seem to organize numbers in a way that they can get the answer. So there's a little trick called box multiplication, which allows you to arrange the numbers in such a way that it's very simple to see and get the answer. So let me give you an example. All you do is create a little box. You should see 4 squares here, and they're all divided in half. This is designed to multiply two-digit numbers together. I'll give you a real easy one first. Let's do 12 times 14 again. And all you have to do to get the answer is multiply them all together and make them fit into the box. Watch this. Here's this box here, and that's for 2 times 1. The top half of the box is for tens, and the bottom half of the box is for ones. So what's 2 times 1? You'll get 2, and that's just a ones. So the 2 would go right there in that box. Now we come down here to this box. That's 2 times 4. 2 times 4 is 8. There's still no tens, so we just have an 8 there. And we'll put a 0 in these spots just so we know they're there. Now we're going to go here. This box tells us what 1 times 1 is. What's 1 times 1? Obviously it's 1. Put a 0. And now this box here is for 1 times 4. So what's 1 times 4? 4. And once again, there's no 10. So now, inside this box, there's all kinds of numbers. But watch what happens. Inside the box, don't count these numbers outside anymore, but just inside the box, see the diagonal lines? All you do is add up between those, and you'll get the answer. Start here on the bottom right corner. The only one number in this line here is 8. So that's the first digit in the answer. We want to add up this column, see between these two lines. So what's 2, 0, and 4? 6. And that's the second digit in the answer. Between these two lines is 0, 1, and 0. That just adds up to 1. And there's a 0 here. So the answer is 168. So 12 times 14 equals 168. And it allows you to arrange your numbers in such a way that make it very simple to get the answer. So let's try another one, make sure you get it. And I'll throw some tens in here. So let's do 35 times 24. The first step is right here. 5 times 2 gives us 10. This is where we get to use our tens box. So there's 10. Just write the number, 10. The next one, 5 times 4 gives us 20. Once again, 20, just like that. No ones, 2 tens. This box here is for 3 times 2, and 3 times 2 is 6, no 10. And then the last box is for 3 times 4. 3 times 4 is 12. And you put it in just like that. And now to get the answer to 35 times 24, you just add those diagonals up in the box. The first diagonal just has a 0. And then between this line and this line, we have 0, 2, and 2, which adds up to 4. This line has 1, 6, and 1, which adds up to 8, and there's a 0 again. So 35 times 24 equals 840. This works for all numbers of all sizes. If you want to try this with 3-digit numbers, just make a box 3 by 3. If it's a 3 by 2, make it a 3 by 2. Whatever size numbers will work with box multiplication, and it's guaranteed to organize your numbers and help you get the right answer. Well, it's time for division. And I really don't believe in division. I think division is reverse multiplication. If I asked you what 15 divided by 5 is, I don't know about you, but my brain automatically says, okay, 5 times what equals 15? So I make it a multiplication problem. So I really don't think division exists. Let me show you what I mean. Here is 5 into 15. That's the way to read this is 15 divided by 5. And the question there basically is 5 times what equals 15? So instead of learning the division process of going into the numbers, just make it a multiplication statement and figure out the missing link. So 5 times what equals 15. 3. It's that simple. Let's try another one. How about 28 divided by 7? 7 times what equals 28? And you'll get 7 times 4 is 28. So that's the easiest way to do division, is to reverse it and make it a multiplication question. Let me give you one more. How about 81 divided by 9? What's the first question your brain should ask is 9 times what equals 81? And we all know now that 9 times 9 is in fact 81. So 81 divided by 9 is 9. Just remember, when you're trying to do division, that it's just reverse multiplication. So practice your basic addition and multiplication skills, and I promise you division will be easier than you ever thought. Thank you for taking the time to go through this program. I hope it had a profound impact on the way you look and feel about numbers. From this point forward, you should have a very basic sense of numbers and a foundation that you can grow upon into wherever you go. I consider myself a mathlete, not an athlete, a mathlete. I'm really into numbers and how they all work together. And just like being an athlete, to be a mathlete, you have to practice the basics. So if you get a chance, please go back to the beginning of this program and go through it and make sure you understand the basics, so that from this point forward in your life, you always feel good and comfortable about numbers.